Hey everybody, and welcome to lesson 4. So we have poured over a lot of review, and that's kind of all chapter 1 is, but it's really good to make sure you feel solid on all this. Last lesson we went over a bunch of operations and order of operations to make sure you can handle a lot of arithmetic. Well, today we're going to dive into a little bit of a wordier part. It's kind of two big focuses of today is to be able to express, take words that express math and change them into mathematical symbols. We also need to understand why some of the steps we've taken over the past few days work, and so we're going to look at some properties of real numbers and operations. So let's dive right in. Okay, so let's talk about some properties. These are properties you've heard before. For instance, we can start with the commutative property. And what I found was, even me as a math person growing up through middle and high school, when they start talking about properties like commutative and associative and all those, I had a hard time telling them apart. And I never really thought about what they actually meant. But it's actually pretty easy to separate out what these mean because we speak, English. If you're listening to me right now and understanding me, you understand English. And in commutative, the root part of this is the same main root in the word to commute. Like if you commute to work or commute to school, that means you drive in or travel. Something is moving. There is some moving happening. And with the commutative property, I'm going to show it to you with an example. That says when I have something like addition, notice their addition, I can take one addition and have two things, and I can move them. They can travel. I can commute them. So I could rearrange them like that. And that would be useful because 3 and 7, we would like to be able to add those together, right? But some people are a little bit scared because they're not near each other. But 3 and x have a plus in between them, have an addition going on, and addition has the commutative property, which says I can just swap them. No ill effects. This is equal to that. So that is the commutative property. The x and the 3 traveled. They commuted. Okay? Now, there is no commutative property for subtraction, but you can force a commutative property by turning it in. Remember, subtraction is just adding the opposite, right? So if we just turn this into an addition, then I could use the it's called the additive commutative property. I could use the adding property. All I would have to do is say, well, this is minus x or subtracting x. Let's turn it into adding the opposite. And then I could commute it because that negative x could come out front, and the and the 3 could, negative x and 3 could switch places. They could commute, but technically there's not really a subtraction commutative property. You have to turn it into addition. So turn into addition. Multiplication is just like addition. If I have 3 times x times 7, I can, maybe I need some lines here to separate these out so they don't all mush together. I can rearrange. I would really like to multiply 3 times 7. Well, the commutative property holds for multiplication. That tells me I can rearrange some things like this x and this 3, or this x and this 7. It doesn't matter. Let's switch the x and the 7. Let's rearrange those. Let those switch spots because they both can travel, they can commute, and now I easily can do 3 times 7. Often we skip over this because we understand so well that I could rearrange all these. So I just go ahead and say 3 plus 7 is 10 and call this x plus 10. Same thing here. We usually do this really quickly in our heads, but this is just the underlying reason as to why we're allowed to do this, and we're not allowed to say this is x minus 3. Division's the same as subtraction. There really is no commutative property. You want to turn it into a multiplication to be able to use it. And remember, division is just multiplying by the reciprocal. So you can turn every division into a multiplication. All right, so that's one property. You should be able to identify this property, and of course we're going to use it. You're just always going to say that you're using it. You're not going to be like, now I am commuting, but we do it a lot. So the next big one is the associative property. Okay, and that's the biggie that people get confused with commutative, because they teach them, they're always taught hand in hand, kind of next to each other. But the associative property, what it does is it allows us, if we have all additions or all multiplications, it allows us to regroup. And once again, if you understand English, associative has the same piece of the word in it as associate, who you are grouped with, who you associate with, who you hang with, who your people are. And so the associative property tells me that I can regroup some things, and I'll show you. Notice I'm not changing the order. None of them are moving. It's still 2, 5, 3, 2, 5, 3. But order of operations would make us do this one first, because we go left to right. Associative tells us that if I have all additions, it doesn't matter which one I do first. So I could regroup it so that I do 5 plus 3 first. I can change who associates. I can take this group and say, you know what, you two are going to be in a group now. I can group y'all. I can make y'all associate. Same thing here. There is no associative property for subtraction. You have to turn it into addition. Likewise for division. There is no associative property. You have to turn it into multiplication. But there is associative property for multiplication. I can notice no one's moving, but I can affect the order by regrouping however I please. I could group whoever I want into a pair. I can associate them. Okay? So there's associative properties. Now I got two more I want to talk about for each of these 4 operations. And the next one I'd like to talk about is the identity property. Now the identity property is quite simple. It just says that you take a number, it doesn't matter what the number is, can you perform the operation and keep that same number? So if this is addition, is there anything I can add not to change a number? And the answer is yeah. If you add 0 to any number, it doesn't change. So it doesn't matter what we have. 7 plus 0 is 7. So this part right here is the additive identity. Adding 0 to something is the identity. Likewise with subtracting, I could take anything and subtract 0. It's not going to change, right? If I take 4 and subtract 0, it's still 4. For multiply, 0 is not going to work. Because if I were to take a number and multiply by 0, that's going to not keep its identity. It's not going to stay the same. So if I take any number, is there something I could multiply by to keep it the same? And the answer is yeah, we could multiply by 1. That is the multiplicative identity. And it doesn't matter what it is. It could be a variable like x. It could be a number like 9. Anything times 1 stays the same. And it's the same thing for dividing. If I take 9 and divide by 1, it's still 9. So these pieces, multiplying or dividing by 1 is your identity. Adding or subtracting by 0 is an identity. It doesn't change whatever we're working with. It keeps the identity. And then we got one last one in this kind of chart that I'm making. Sorry, I don't draw the straightest lines. The last one, let's see if I got enough space, is an important one. It's the inverse property. Now what an inverse is just how we undo things. So if I take any number, how do I undo it with adding? Well, how would I get rid of 5? I would need to add -5. and it would add to 0. So that's how you do an inverse, is you got to actually take the opposite number and add it to it. Subtraction, I don't even know if I really want to dive into subtraction and division one, but if I were to take 5, what would I need to subtract from it to equal 0? To get rid of it, to undo 5, it would just be the same number itself, 5 minus 5. Multiplication is an interesting one. So if I were to take 9, since it's right there. I don't feel very creative today. How can I undo 9 with multiplying by something? Well, look at adding. We use the inverse. Wasn't there not inverse, what's this called? The opposite. Wasn't there another word we studied the other day? How about the reciprocal? The reciprocal of 9 is 1 over 9. And these things, when they multiply, the 9s will divide out, and you just are left with 1. Likewise, if I have 9 and I'm trying to find how to get rid of 9 dividing, it's just plain 9, which is 1. Which should make sense, because dividing by 9 is the same thing as multiplying by the reciprocal, multiplying by 1. So these are the same step. Same thing here. Subtracting, it's just adding the opposite. So those are the inverses. That's how we undo things. Okay, and then there is the distributive property, which just gives us the ability to kind of fast forward some steps. So let me show you. Usually we write it without a multiplication, but I'm going to put a multiplication dot in there to help us visualize what's happening. Now I will go ahead and tell you, this could be multiplication or division. It doesn't matter. You can actually distribute if this is simple enough. If it's a single term, you can distribute a division, because dividing is the same thing as multiplying. Remember, I told you that I could teach the class with two operations if we wanted to. And then adding is the same thing as subtracting the opposite, subtracting the opposite is the same thing as adding. So this could be plus or minus, it doesn't matter. That's irrelevant. Okay, so let's actually look at how this works. What it does is, takes this 4 times and applies it to everybody inside. So x gets the 4 times x. 4 times x. Same thing for the 2. First, let's bring our operation. Plus 4 times 2. So I know this is the one thing everybody remembers from algebra is the distributive property, but just making sure, just in case you were asleep that day or were sick and never understood it, it's quite simple. It's just this 4 times goes to every single term inside this parenthesis set, and we bring the operation that's in between them along for the ride. So 4 times x is just, we can write that as 4x, bring down our plus, and 4 times 2 is 8. So we know how to distribute. That's great. Alright, so now let's use our properties. This is something like what you might see on the test. So we have what properties of real numbers justifies step I and step 1 and step 2 for the following. So I have 5 plus x minus 2. And we look at what changed. Let's actually cover up this. On the test, you can take a scratch sheet of paper and cover up, so you can look just at one step to the next. I didn't add or subtract anything extra. It's the same 3 terms. I didn't add parentheses. I didn't distribute. But notice that the 5 and the x switched places. They moved. They traveled. I know that that is a commutative property. And if I wanted to be really specific, the operation's adding, so that's an additive. Really, the most important part is that's a commutative property. Okay, and then let's look at what happened, what changed from here to here. Well, the x, the 5, the 2, the plus sign, the minus sign are all in the same spots, but notice that order of operations, I would add x plus 5 first, then worry about minus 2. But notice I've added this grouping symbol in here. Well, that's the additive associative property. I've regrouped them. So there, you might be asked to do something like that on a test and on my worksheet for sure. So make sure you could look one thing at a time. All you're looking for is what changed. Why was I allowed to make this change? Well, these two moved. That means they commuted. Is commutative. I regrouped. I reassociated. So it's an associative property. All right, let's work on the last half of the lesson here, or the last gist of the lesson is being able to take English words and turn them into some algebra. That's the most usefulness of math, is being able to solve real-world problems, being able to solve traffic flow problems, or medicine dosing problems, or cure cancer, or things. Most of the math behind those things, you need to be able to take people's words and turn them into math. We're gonna just start with this looked better on my worksheet, but my typesetting software doesn't really convert real well to Smart Notebook. But anyways, so we're just gonna basic 4 words, or 4 operations: addition, subtraction, multiply, and division. This is in the textbook, which you have access to through my math lab if you have that. You can Google these type of charts. Some of the words are more controversial, but some of them are very obvious. Like obviously add means to add, and subtract, multiply, divide. But let's see, some of the ones that get people like more than, less than is subtract. Those are ones that get people. Difference is a one that confuses people a little bit. I think everybody knows the rest of these. You can pause and stare at these if you need to. I'm just going to jump into some of the examples, which I think I have on the next page. Okay, and let's look at just one at a time. So this is we start very easy, very obvious. 9 times a number plus 3. Now, I do want to kind of underline and break down some things. So obviously I have 9 times something plus 3. So 9 times, so let's see, 9 times a number. Now, I haven't told you what the number is. We don't know what it is. So what we're going to do is we're going to use a variable or a letter to hold that spot. So if I just say a number, sometimes I may say a number x. I may tell you what to use. It doesn't matter. But 9 times something, so let's call that something x, plus 3. So that's really easy. I feel everybody should be able to do that. We're going to dive into some more difficult ones. So let's look at this one. 6, I didn't mean to use blue on the blue. 6 less than a number. Well, I know we're dealing with a 6 and an x. What does less than mean? That means to subtract. Now, the one thing we have to get is we have to get this subtracted in the correct order. And less than is one of those that are a bit confusing because it's backwards. It's not actually what you think, 6 minus x. That is not right. It's actually x minus 6, and I'll explain why. Think of where you would use this in a sentence. Let's say I ask you, hey, what is 6 less than your age? 6 less than your age. So let's say you're 18. 6 less than your age would be 12. Well, how would you get that? 18 your age minus 6. So this weird less than phrase is actually backwards from how it's worded. You see the 6 first, yes. Let me finish writing the word backwards. You see the 6 first, but the x is actually going to come first. Only when we use the phrase less than. There's a few other ones that are kind of funny order. Just need to practice them and be made aware. So let's just grow this a little more. So 8 less than. So remember what that means. That means it's going to be minus 8. Something minus 8. So what are we somethinging? The product. What does product means again? That means to multiply, right? So we're going to have some sort of multiplication. So we have minus 8. What is it being minused from? Some sort of multiplication. What 2 things are we multiplying? 2 numbers. So I don't tell you again, so you may want to go with x, right? Well, what's the other number? Do I put x as well? Well, no, that would mean they'd have to be the same thing. I don't know. It's just 2 different numbers. 2 numbers. They could be the same. They could be different. So we're going to use the product of 2 different variables. X times y. That's a tricky one. And then that just means equal sign 10. So it is equal to 10. That was a tricky one. Had a lot thrown in there. I'm trying to make sure you see everything that we could throw at you now. You practice it on your worksheet, then the test should feel easy. Alright, so here we go. We got the sum of. Well, sum means that we're adding. So what are we adding? we're adding twice a number, and tells us where the plus sign goes, twice a number and 8. Well, twice a number, that means 2 of those numbers, or 2 times x, is 23. So we're adding 2x and 8, and it is 23. Okay. Ooh, this is a good one to talk about. So we see 7 less than. So I know that means I have minus 7. Well, what are we subtracting 7 from? 12% of a number. Well, this is something we need to discuss. How do we do a percent of? Now, we've talked about of, or we didn't talk about it, but it's in the table as a times. And that's true. We know this is x. So we're multiplying something by x. Well, what's 12%? Let's see. 12%. Every percentage is going to need to be converted, if we're going to use it in a formula, to a decimal. And that just moves the decimal over twice. Or the word percent literally means to divide by 100. Like centimeter, there's 100 centimeters. If you take 12 divided by 100, you get 0.12. So 0.12 times x minus 7. So you might see this on a test. If we say 12% of, that means turn the number into a decimal and multiply by whatever is after the of. Okay? Is that really about all the examples I have? So let's jump on this one. So twice the sum. Now twice means 2 times something, right? What does a sum mean? That means 2 numbers being added. So this is where twice something being added. Let's see what's being added. A number and 5. So x plus 5 is being doubled or multiplied by 2. So be very careful with just talking yourself through these. Okay? You're doing this as an online course. You can sit there and talk to yourself all you want to at your computer until it feels good. Okay? Now I got one more kind of thing. It is still going from words to algebra, but we want to kind of work on dealing with like some more traditional word problem setups. These are not word problems. We're just practicing writing the mathematical expressions. So let's just say that you have a new job and it pays $8.50 an hour. How much would you receive after working 3 hours, or 8 hours, or 20 hours? Well, how does this make sense? You're making $8.50 for each hour. How does that relate to, if I work 1 hour, I get $8.50, right? If I work 2 hours, I get 2 of these. So mathematically, what we're doing is we're multiplying by your number of hours. So 3 hours, that would just be $8.50 times 3, and that would tell me how much money we're making. Which, let's see, I don't have a calculator right here with me. I believe that is $25.50. Of course, you can use a calculator. $8.50 if you worked 8 hours times 8. That would be $68. Notice I'm trying to include units. Make sure you try to include units. Don't leave them out. If you worked 20 hours, that's half a work week, or that's part-time. A lot of college students work part-time. You know, you work your 20 hours. 8 hours is the typical work day, but I guess 4 if you're working 20. And let's see, what would that be? That would be $170. So this is just trying to help us set this up. So let's talk about what these things are. This is commonly known as a linear expression. It has this set number known as the constant. The constant is something that doesn't change. It's not changing. You are getting $8.50 throughout the entirety of this problem per hour, right? That is a constant amount. Now what's changing throughout the problem, or can change, is how many hours you're working, right? So that's called the variable because it can vary, it can change. All right? So whenever we have this relationship and it's per hour or something like this means that it's going to be, so let's use a variable to represent this varying amount. We could call it x. So then if I wanted to write an equation, I could call it 850 times x, because that's what we did, is we did 850 times the number of hours to figure out how much you would get each time. I do want to say this is a special type where it gets multiplied by the x for each one. This is also known as a rate. Alright? Because it's for each hour, that lets us know it's just going to be multiplied by the variable, our rates. Okay. So let's see, what would we ask you to do on a test? We'd ask you to do something like this. Ignore the symbols, it messed up when I converted it over. So write the following algebraic translation. Let's say you rent a car, they charge you $25. It's hard to see this, let me rewrite it more neatly. They charge you $25 to rent the car and 25 cents per mile. Okay, so what's constant? Well, the $25 is certainly not changing, nor is the 25 cents per mile. They're not going to up the rate while you're driving, are they? They're not going to be like, well, now it's 30 cents just because we feel like it. No, these are constant. They're stuck values. What's the variable? Well, what's the only thing allowed to change throughout here is how many miles you drive. So miles driven. That's what can change. So let's let that equal x. Let's call that a variable. That's x, because this is the thing that can vary. Can we write the algebraic expression? Well, one of these, remember up here I mentioned, is going to be the rate. That means it's going to be multiplied by the x. Which one is it? Which one is related to the x? Well, that's the 25 cents. That's the constant that is our rate. That's the one that will be multiplied by our x. Well, we still have to pay this $25 as well. So that just gets added on to it. So there is how much our total cost would be for renting this rental car. It's $25 plus 25 cents times each mile. On the test, you'll have to be able to come up with this last part. All this extra was just to guide our thinking to this. Okay, so we're almost done with test 1 material. That was lesson 4, and there's one more lesson. So make sure you're wrapping up all your work. Make sure you do your worksheet. Make sure you're getting yourself ready. And I'll see you next time. Take care.